Hi, welcome back. The first keynote speaker is Dries El Hadani. Since September 2023, Mr. Dries El Hadani is a senior advisor D1 at the Office for Outer Space Affairs. He provides expert advice, support, research for the activities and programs implemented by the office in the fields of space science and education. Manage the office activities related to the United Nations Affiliate Regional Center for Space Science and Technology Education. Dries brings to this position more than 30 years of experience in the field of remote sensing and space technology application and development. Over his career, he has gained expertise and knowledge of the space sector and at the national and international level, and substantive experience in diplomacy by negotiation with the international cooperation agencies and mechanisms, as well as serving as the first vice president of the United Nations Committee for the Peaceful Uses of Outer Space from June 2000 to June 2004. He served as the director of the Moroccan Royal Center for Remote Sensing from 1998 to 2023. He holds master's degree in physical science, applied remote sensing from Pierre et Marie Curie University in Paris, France, an engineering degree from the Mohammadi School of Engineering, Mohammed University in Rabat, Morocco, and a master's degree in business administration and management from the Higher Institute of Commerce and Business Administration, Morocco, as well as bachelor's degree in law. He is fluent in Arabic, English, and French.
Can I do my presentation from
there or from here?
Good morning, everybody. Once again, welcome to all participants to this conference. And it's my privilege and my honor to deliver this first keynote on the space-based solutions for integrated water management resources. And also, it's an opportunity for me to share with you some thoughts and some ideas on the UNOOSA actions and programs to foster international cooperation in the use of satellite-based technologies for sustainable development. Slides, please. Well, before maybe go into the details on the role of space technology in the field of water resource management, let us explore the situation of the water resources and mainly the crisis that we are facing through some statistics that give us an overview on this situation. As you know, according to United Nations by 25, which is today 25, around 2/3 of our global population may face the repercussions of water stresses, with 1.8 billion people struggling with absolute water scarcity. These figures are not just statistics, but represent a call to action for all of us. Our situation is further compounded when we consider the statistics across clean drinking water. The World Health Organization reports that nearly 800 million people are deprived of basic water services, while more than 2 billion are compelled to use water resources that are contaminated with fecal matters, for example. This isn't just environmental issue, is also a profound health issue. We are also confronted with the immense pressure placed on water resources by agriculture. We have been saying this in this morning in this opening remarks that agriculture is the largest consumer of water resources, accounting for 70% in its global use. This is especially pronounced in developing countries where these statistics are up to 95%, where these countries are facing a very huge problem. You know that the economic ramification of water scarcity cannot be overstated. The World Bank, for example, warns us that the lack of water exacerbated by climate change could diminish the GDP by 6% in certain regions. Precipitation problems like immigration, igniting conflicts, and underpinning development. I think we have some issues with the presentation from time to time. This crisis is triggered by some factors that are impacting the management and the quality and the availability of water resources. The first one, as you know, is the climate change. We are confronted to a reality which is now being a part of our daily life. The climate changes are altering precipitation patterns, increasing temperature, bringing more frequent and severe water-related events such as floods, drought, etc. These thematics or climatic impacts or climatic change shifts require adaptive management strategies that space, for example, could provide some solution. Overexploitation is one also of the challenges that we are facing. The alarming rate of groundwater extraction is leading to rapidly falling water tables. When coupled with the unsustainable agriculture activities and industrial practices, this overexploitation endangers the availability of fresh water for future generations. Also, pollution poses another disastrous threat on our resources, water resources. Industrial wastes, agricultural runoff, urban sewage not only contaminates our rivers and lakes, but also introduce complex chemical pollutant and microplastics that challenge our traditional water treatment methods. Each of these challenges contemplate the complex web of issues we must navigate in water resource management in this evolving world. Population growth and urbanization is one of the critical issues that we are sitting. As cities are expanding, the demand on water in these growing urban areas intensifies, placing immense strain on already overburdened water supply and sanitation infrastructure. The urban surge calls for innovative solutions for sustainable management of water resources. The other point brings to the core of functionality is infrastructure. Aging or inadequate water infrastructures is a silent crisis leading to significant water losses in many regions. There is market dock facilities capable of efficient water use, treatment, and recycling. And we heard from opening remarks this morning that, for example, Costa Rica is facing water rationalization and electricity water rationalization due to this kind of issues related to infrastructure. Lastly, we navigate the complex field of transboundary water management. Water resources do not adhere to man-made frontiers and borders, resulting in some cases conflicts over shared resources between regions and countries. This may raise some legal and political challenges in managing the cross-border water bodies and make it more difficult. The other list of issues that are impacting our capabilities and the availability of water resources are linked to the profound impact of ecosystem degradation on water. As you know, the loss of wetlands, for example, and other critical ecosystem that facilitate natural water purification, for example, is a crisis that extends beyond environmental concerns. It strikes the heart of our water resilience. As this ecosystem diminish, so does the rich biodiversity they support, which is crucial for the natural balance of our water systems. Moreover, we are faced with economic and financial constraints that hold back our progress in sustainable water management. Limited funding, for example, often means that essential maintenance and improvements to water infrastructure are sidelined, which can exacerbate existing challenges and also hinder efforts to balance economic growth with sustainable water resource management. Lastly, we struggle with policy and governance issues. So you are aware that inconsistent or inadequate water management policies and lack of integrated approaches undermine our efforts to manage water sustainably. On the other hand, we have also some critical issues related to social and cultural components that influence water resource management. The disparity in access to clean water across different social strata remains a significant challenge. Water, a fundamental human right, is often luxury beyond reach for many, particularly in marginalized communities. Moreover, deep-rooted cultural practices can have profound effects on water usage and conservation, sometimes exacerbating water scarcity issues or hindering sustainable management efforts. On the front of technological evolution or innovation, while we have the vision and the know-how to implement sophisticated methods for water conservation, recycling, and treatment, these advancements are not uniformly distributed. The technological divide leaves many regions, many countries, essentially less developed ones, struggling with outdated systems and methods that are often inefficient and unsustainable to manage water resources. Addressing these social, cultural, technological challenges require a multifaceted approach that respects natural complex and bridge technologies gaps. Through international cooperation, capacity building initiatives, we can ensure that advancements in water management technologies are accessible and adaptable to the needs of global communities. There's a problem with this remote control. Sorry. Okay. So for sustainable water resource management, I think we have at least four elements or four pillars that enable us to achieve this objective, which is integrated water resource management. The first one is data collection and management. As we know that the adage that say you cannot manage what you do not measure is very important and holds particularly true in water resource management. Reliable data on water quality and quantity from backbone of strategic planning, decision-making, crisis management is important. Continuous observation underpinned by space technology provide us with the necessary insights to safeguard and manage these precious resources with the precision it demands. Turning to technology and innovation, as I said, is one important element in water resource management. It's evident that advancement in the fields such as remote sensing, geographic information, satellite communication, positioning systems, as well as automated water management systems have revolutionized our capacity to monitor and manage water more efficiently. Innovations in water purification, for example, recycling, desalination technologies are not simple conveniences. They are essential components in the sustainable management of water resources. The third pillar in this integrated water management approach is education and capacity building. The educating communities, policymakers, water managers about sustainable water practices and the potential of space-based technologies is foundational for self-efficiency. This empowerment enables states, communities, and government to take ownership and manage their water resources effectively, adapting to both challenges and opportunities. Lastly, policy and governance structure our approach and inform our actions. Strong, transparent, and enforceable policies are the framework within which we operate to protect water rights, allocate resources wisely, and manage this risk associated with water scarcity, pollution, and climate change. Sound governance underpins very successful water management strategy, ensuring that sustainable practices are not only planned but also implemented. Okay. Now coming to the role of space technologies in water resource management. You know that the pivotal role of space technologies plays in integrated water management is evident, and the strategic and economic significance of these technologies and their applications is multifaceted, stemming from their ability to communicate, observe, and locate with precision and extent that were unimaginable just a few decades ago. The first space technologies through SATCOMs, for example, enable us to collect, disseminate data and information anywhere, irrespective of the state of ground-based network infrastructure. In the context of integrated water resource management, this capacity means that crucial data on water availability, water quality, water usage can reach decision makers and stakeholders anywhere, anytime, facilitating timely and informed response to water-related challenges. The second element is observation, which is provided by satellites. Observation is where the strength of space technology truly stands out. Satellite allows us to accurately monitor and spot on Earth across a broad spectrum of frequencies, providing a non-intrusive, comprehensive view on our planet water resources. This ability is invaluable in detecting changes over time, for example, from the depletions of aquifers to the decline and flow of glacial melts, enabling us to manage our water resource management with an informed A on sustainability. Lastly, the precise location, which is provided by GNSS systems of space technologies, have revolutionized the way we interact with our environment. By locating fixed or moving objects across the globe, we can track water flow, manage irrigation systems, even guide emergency services during flood events, for example, with increasing level of precision. In sum, the contributions of space technologies to integrated water resource management are transformative, making them indispensable tools in our quest for sustainable water management practices. As it was said this morning in our presentations, for example, this concerning the contribution of space technology to sustainable development goals implementation. Okay. When it comes to the role of space supporting the sustainable development goals, the first one directly linked to water is the goal 6, which seeks to ensure that clean water, safe drinking water, and effective sanitation is available for all. And space technology is contributing to this through a variety of mechanisms, by monitoring water quality, meteorological forecasting, for example, access to information or infrastructures. And this also is related to other development goals that are directly impacted by water resource management, such as goal 2 on food security, goal 3 on public health, and goal 1 on no poverty. It's also impacting the other SDGs, like the third one on the health, the one on poverty, as I said, and no hunger also. I was told by moderator that I didn't get more time, so I was trying to skip some slides just to go to the examples that we are sharing with you on how satellite data can support integrated water resource management. As you can see from the slide, space technology such as satellite imagery, for example, is providing critical data for monitoring water resources on a global, regional, local level. Soil moisture, for example, surface water extent, snowpack levels, for example. All these elements are vital for resource management. Also, satellite data, space technology is providing insight into water cycle dynamics by providing information on soil moisture, for example, effective irrigation, disaster management, also when it's related to water, such as flooding, drought, are supported and using satellite data to support decision makers and policy in implementation when it comes to this issues related to disaster management. A few examples, specific examples, for example, for weather forecasting. As you know, we are relying on satellites on this issue. They are the main element. Data from on atmospheric water vapor, for example, precipitation patterns are provided by a series of satellites, and we have a very large number of programs, such as the GPM constellation, the Meteosat, for example, the other GOES and other satellites that are now providing a very large range of data and range of systems that feed modeling and feed mechanisms that provide weather forecasting for agriculture, for disaster management, etc. Precision farming, for example, which is related to water in some link somehow. And based on satellite data, we are able now in different regions of the world. It started in United States, for example, in Europe, but now also some startups in Africa are providing services on precision farming by providing information to agriculture farmers in different regions. So this is going to the level field through the precise management by monitoring crops, crop health, soil conditions, moisture, for example. And one of the powerful tools, for example, that are used in this issue is the NDVI, which is the Normalized Difference Vegetation Index, which provide very valuable information on the health of vegetation, and then can support farmers and agricultures in providing the right, for example, amount of water, etc. Other examples that are also provided in these slides, the one on the use of of satellite data, for example, to monitor drought in different regions. In Africa, for example, many countries are facing drought crisis, drought disaster, and satellite data is one of the powerful tools to monitor this drought by providing data and also by providing early warning systems to inform farmers and government on the pending issues and to improve the capacity of the different kind of actor to be prepared to face this drought and to take actions on the field to improve the quality of the activities that are provided by farmers. Can also have some examples from other regions of the world, coming from India, for example, when they are using this kind of satellite data for efficient water management based on, for example, a system that is developed by ISRO, which is the Puhan satellite platform, which provide critical data for efficient water management in irrigation in intensive regions. This satellite help in planning and managing the canal network and irrigation schedules. Conservation of rice farming also related to the optimization of flight time, which means that we are saving water and we are also improving production. This is based on satellite, radar satellite data that provide information on waterlogged conditions and also support farmers to manage the flooding operations. In this field, I would like to mention some of the activities that are provided by UN system and by other organizations that support the use and the integration of satellite data, satellite technology in water resource management. UNOOSA, for example, program for satellite applications, Space for Water project, which is supporting this conference, UN Spider program. All of this are programs that are managed and run by the UNOOSA to support developing countries to develop capacities in using satellite data in access the benefits of satellite data and to have the adequate capacity to use and to implement this data. In this field also we have regional centers in different regions of the world that are affiliated to the UN system and supported by UNOOSA. These regional centers are providing education opportunities in the applications of satellite technologies, remote sensing, telecommunication, meteorology, etc. UNESCO is one of the active UN institutions in water management and providing a lot of capacities. We have also the group on Earth observation that is also cooperating with UNOOSA on initiative that integrate satellite data and provide access to information, etc. So we have a lot of other mechanisms that are available to foster and to develop cooperation in the field of the use of satellite technology in water resource management. Just a few words. I will not go to details in the slides. Maybe you can have a copy of the slides and have more information on two elements. One is the United Nations Committee on the Peaceful Uses of Outer Space, the COPUOS, which is the mechanism within the UN system that was established in 1959 to develop cooperation in space applications, to promote space sciences and technologies, and also to provide the legal platform or legal framework for space activities. The COPUOS is the main committee, but also we have two subcommittees. The first one is Scientific and Technical Subcommittee that is dealing with all the scientific, technical aspects related to space applications, and also the legal subcommittee. Each of them has meetings each year in Vienna to discuss these two aspects. And the UNOOSA, who is the operational tool or the operational arm of the COPUOS, is in charge of the advancing international cooperation through programs that I said earlier on how we can develop capacity, how we can foster cooperation, how we can implement the recommendation of the committee and the resolution of the United Nations when it comes to space application and space legal framework. I will finish my presentation just by recalling what I said this morning in my presentation of the new strategy that was developed by the office presented to the member states last January. We have 5 priorities or 5 strategic objectives. The first one is space sustainability. We have to ensure that space is safe and sustainable so we can continue and we can make activities in space and services provided by space sustainable, but also to preserve this resource for the future generation. The second priority is climate action. So we are developing activities, access to data, access to information, so we can support countries to integrate satellite information and satellite technology in climate management. SDGs, we have been presenting this many times, and our priority is to support UN system, but also member states to integrate satellite data in achieving the SDGs implementation. Developing countries, this is the core of our activity, and this strategy is aiming to have a specific emphasis on Africa and the needs of this region, but also we would like also to promote and to reinforce the engagement and the cooperation with all the stakeholders involved in space domain through the partnership and cooperation and programs, joint programs with intergovernmental organization, private sector, and civil society. So this is an overview on the office activities, and I will be available to answer any kind of question and provide more details on the programs and the activities. Thank you.
Thank you, Mr. Dries El Hadani. I want to highlight the importance of the good quality water to achieve the important objective of the 2013 agenda. For the next keynote speaker, we have the Dr. Marcial Garbanzo Salas. Dr. Garbanzo holds a PhD degree in physics from the University of Western Ontario and works as a professor for the School of Physics at the University of Costa Rica. The main interests of Dr. Garbanzo are remote sensing applications, including radar and satellites, as well as the development of instrumentation with direct applications in industry and academia. Marcial is a co-chair for the Satellite Data Requirement Group in the World Meteorologic Organization, RA34, and collaborates with the VLab office in satellite training around the world. Marcial coordinates the Climate System Observation Laboratory dedicated to instrument and service related to meteorological products and their applications. Marcial also acts as a director of the Department of Atmospheric, Oceanic, and Planetary Physics that observes the undergraduate program in meteorological and activity participate in the graduate program in atmospheric science and hydrology.
Gracias. Voy a hacer la charla en inglés, pero si tienen algún comentario o alguna pregunta en español, por supuesto.
I'm going to make my presentation in English, but if you have any comment in Spanish, we can do it.
I'm going to be presenting you kind of the other side of satellite from the WMO perspective. So let's see if this thing gets to work at some point. Okay, let's do it now. So I'm going to be covering 3 main areas today: the WMO, then the VLab, and then the SDR. In some areas like geo, SDR is usually not heard of, but I'm going to be presenting today what we do, how we do it, and how you can participate of that, which is quite important for satellite utilization. So WMO, I'm not going to spend too much time on the definitions. You can read those or look them up yourself. But WMO provides this framework for international cooperation. And that cooperation actually, once it's done properly, provides you with a lot of data for satellites, a lot of training material, and a lot of capacity that you can learn, understand, and use for yourself. So the United Nations specializes in, the WMO specializes in weather, climate, and water. And I know water is kind of important in this room. It's got a lot of members, but this cooperation and coordination with space agencies, as you're gonna see in a second, it's crucial because in the past there were space agencies and some users in some places, but now we have connected them. And I think that's gonna be very important for the utilization of this data. So you understand how WMO works. It's divided in regional associations. We are in region 4, which is North America, Central America, and the Caribbean. There's also region 3, but because we are connected to the satellites that we use from NOAA and from other space agencies in the area like INPE and CONAE in Argentina, we basically operate together. So region 3 and region 4 in satellite, we operate together. This is the regional structure. I'm not gonna spend too much time on that because it's just the regional structure. My position is actually the lower green square there is the focal point in satellite data requirements. I coordinate satellite-wise everything in region 4. And there is some of the goals, you can read those. I know the presentations are gonna be available, so you can read the goals if you're interested in those. But let's move on to the space program. So the space program, it coordinates satellite and space-related activities. But when it says coordinates, you have to remember that only a few agencies around the planet have the ability and capacity to send satellites to space. So if the only users of those satellites are the ones that send them to space, it's very limited, super limited. So this coordination is designed to connect the satellites, the data and the products to the users, the final users. And that's where we, the regions, come into this. So let's give it a minute. There we go. So the space program, there is some keywords. Those 9 squares there, they are the areas in which the space program develops. But there is some very important ones there. For example, the frequency coordination. We rarely think of the frequency allocation for the satellites and the instruments. They do that coordination. So they have to coordinate with, for example, the 5G networks. The 5G networks, everybody likes to watch movies on the phones, so we need more bandwidth for the phones, but that actually collides with the utilization of frequency bands for instrumentation and telecommunications with the satellites. So you have to coordinate those really well. But specifically, I'm gonna be presenting in the following slides this access to satellite data and products, this training for those satellites, the regional activities, and if we get some time, probably mention something about calibration. So I have a few QR codes in there in case you want to grab those and look for the websites, because some of them are really important. So there is this website called Oscar Space. Who have ever heard of Oscar Space? Nope. Okay, couple of hands. So Oscar Space is a website, it's a portal from WMO where you can find all satellites, all instruments, all products from the satellites in environmental and meteorology areas. This is super important because if you want to find some data for study or for whatever reason you need it, it's there. So let me just show you an example. So this is the portal. You can go there with the QR code I just showed you. And you can write in there keywords, for example, water, and you can look for satellites that are related to water measurements. And here's an example. If you look for the GPM core that the previous presenter was actually showing in one of its slides, you can look for the GPM core, and you can learn about it. So you can see when it was launched, when it's expected to finish, the end of life of the satellite. So if you're planning to create a product out of this information, this is as far in the future as you will be able to do it, which is crucial for some of the things we do. There is also the frequencies of the instrument and who to contact if you want to know more about it, and even some links to the websites where you can find the information. And I think that's very important for the utilization, because some people they say, okay, I want to build something with water for this, but what satellites could do it? So they try to go to each of the space agencies' websites, trying to find information. And it's a space agency, they have a lot of information. So navigating it is gonna be a pain. So here in this website, you go, you look for the instrument, you look for the satellite, and it's from all space agencies in one place. So it's pretty useful. So VLab. Once you have all this information, all this data and the products, you need to train people on how to use it. So VLab is a global institution, and we have been doing virtual since before it was cool to do virtual. So we started doing that 20 years ago. That's why it's in the name, Virtual Laboratory for Meteorology Utilization. So we have centers of excellence and we have satellite operators. Our centers of excellence are those institutions that are capable of training you in satellite. And the satellite operators, they launch the satellites, but they also create training material that you can use to train people. So here is the list. You can see it's a lot of us. I think the slides, well, it's cut off here in the screen, not over there. So from Australia, there is many other places like Costa Rica. We have one here at the University of Costa Rica. And all these centers of excellence, they have professors, trainers, technicians, and people who actually do satellite things. And you can go there for training, and we can train you. And we usually don't do it by our own. We usually coordinate the trainings. We coordinate heavily with Barbados, Brazil, Argentina, United States, and Europe, because it's the most satellites that we use. But we can also coordinate with China, we can coordinate with India, we can coordinate with other space agencies as well. Okay, so we run a lot of satellite courses, hundreds of satellite courses every year, all over the planet. Yeah, so you can see there is the Kenya one, China, there is one in Costa Rica for newcomers into the area. So at the University of Costa Rica, we have a first and second year meteorology students course for satellites. So they're just learning physics and they're already learning about satellites as well. We don't wait for them to be like advanced to go into this amazing field of satellites. So the regional focus group, have you ever attended one of those? No? Okay, there's the QR code. You can go there, put your email, and then you'll get the announcements of the activities. We have meetings every month, and we look at the perspective of the atmosphere, what's happening, what's gonna happen in the future, short range, medium range forecasters, using models, satellites, and others. We are quite a nice group. We get along really well, and it's because we work a lot together. So there is Bernie Connell. Her picture is not there, but she's kind of the engine behind everything. For example, the Americas Regional Focus Group has been running over 20 years. 20 years doing this every month. The Australia one is over 10 years, and there is other regional focus groups in Africa, Oman, Morocco, and other areas as well. Skills and knowledge. Once people go into the field of satellites, they start asking questions like, okay, what should I know? Well, we have that mapped. So there is a skills and knowledge document that you can find in that QR code over there. It's in 6 languages, and it tells you one by one the skills that you need to acquire to effectively work in satellites. So if you need to differentiate coasts from water, mountains from valleys, forests from other areas, it will tell you exactly what you need to know. And this is now for meteorology. We're creating the same for agriculture, hydrology, and some others as well. Finally, in this talk, I'm going to be mentioning the Satellite Data Requirements Group. As I said, in the past, satellite space agencies were doing what they do, sending satellites into space, and some users could get the data, and some users could actually utilize it for something. But then we created, and when we said we created, it's the region created the Satellite Data Requirements Group. We have a quick guide that explains what we do, so I'm not going to go into full detail of what we do. But in the quick guide, it's information about how we do it, how we connect these final users. And we're talking about final users. And this can be institutions, it can be countries, it can be lone wolves, like people just at home saying, okay, I would like to do this for my location or whatever. And we connect them to the space agencies so they have what they need. If it's data, if it's products, if it's training, we can do that. And I'm going to be showing you an example in a minute. Let's wait for the slides to change. Okay, that one. So this is what happened last year. Mexico got hit by the Hurricane Otis, and they had a problem with some of the information that they needed. So they contacted the group. I'm the co-chair, Diego Souza from INPE in Brazil is the other co-chair. So they contacted us and saying, okay, we need data for this emergency. And there's the timeline there if you want to read it. But it took us about 20 hours, less than 21 hours to go from we have a need of satellite data to we already have the data being utilized. And it was from Mexico, a request to a space agency in Argentina, CONAE. So we help facilitate that. So if you need data, please talk to us. We can help. And we do a lot of things. I'm not going to go into details, but we do with the help of the Costa Rican office, and I see Federico here, so thank you for all your effort. So with the help of the Costa Rican office and the Americas office, we do from politics all the way down to technical stuff. We even have a technical group inside the satellite data requirements group. So if you have a system that is supposed to get Amazon data for whatever you do and it's not working, you contact us and we will put you in touch with them so they can actually help you. And it's very technical. We also run the regional surveys. If you try to help people, you need to know what they need. So in this case, we run the regional surveys. We have a dual approach. We have the formal approach, which is governments talking to governments and others. And we have the informal approach, where we go to individuals and organizations, ask them, what do you need? So with this information, we know the utilization. So here's the areas of application. And you can see there is a lot of information there. It takes a long time to analyze these surveys because you can ask them, why are you using this product? How are you using this product? Do you need more training in this? Do you need basic or advanced training in this? And that's actually the next slide, I think. Yeah, that's the training needed. As you can see, there is utilization in many areas there. It can be satellite data processing. If you have problems there, okay, we can train you in that. Or we can point you to the right direction to who can train you in that. Hydrology, water modeling, utilizing satellite data. We have many trainings that we can actually share. And I think in order to give some room for questions, I'm going to end there. So thank you. Okay.
Thank you, Dr. Garbanzo. Now, the next keynote speaker is Leonardo Cascante. He is the coordinator of the Water Department, Development Department of the Ministry of Environment and Energy of Costa Rica. He is an agriculture engineer and has a master's degree in project management. Mr. Cascante has worked for 13 years in the development of projects related to water management.
Buenos días, mucho gusto. Saludo a las personas
Morning,
en el panel, a las personas que están de manera presencial
and
y a los
those
que están en la
who
zona
are
virtual.
in the room and
Desde el
virtual.
punto de vista de la Dirección de Agua y del Ministerio de
From the
Ambiente,
point of view
a desarrollar
of the
tres
Ministry of
temas
Water and
en esta
Environment, we are
presentación.
going to have
La primera tiene que ver con el marco
three items
normativo,
of a presentation, regulatory
segundo,
framework,
cómo estamos como país,
how we
diferencia
are
de los
as a
que
country,
podemos tener
and the
con
relationship they
la
could have
generación de información.
with generation information.
Tenemos que hacer la pausa entonces, para este consecutivo. ¿A la pausa? Nadie me va a escuchar a mí. Estoy. Okay, so we're going to retake the session. I was telling you that from the point of view of the Ministry of Environment and Energy, we are going to develop 3 topics in the regulatory framework, the generation of information, and the steps to follow and the challenges that we have ahead of us. With regard to the regulatory framework, it is ordered in the scope. It has to do with, in general, the country has a law for water that is dated from 1942. And it is the one that gives the legal framework to the country for the management of the hydro resource. As you can see, it is a law that is more than 70 years old, and it could be that it has some limitations, mainly in the challenges that we are facing to this day. The second element would be the economic side. The country has 2 instruments that are the ones that allow us to make the assignment for the allocation of in the use of water, and that regulate the quality of the water, the residue water. It is an instrument that is technical, but it has a component that is economic also, which is the one that generates resources for the protection and for the management of the hydro resource. The first one is the canon for the residue water. It establishes the parameters and the limits under which the water can be spilled once it is treated. The second would be the canon for the use of the water, which establishes the use of the water. For example, human consumption, tourism, livestock, and also irrigation. To the right, we have the technical aspects. These are instruments that have a technical legal relationship and that regulate topics that are very specific. For example, the drilling in the subsoil. This is something that is very important because at the country level, one of the main sources of water that we have is the underground water. And the regulation of the drilling of that water is what allows for an adequate use of the hydro resource. This regulation that regulates the drilling of the water has been updated, taking into consideration the current demands. For example, the monitoring, the generation of information or data, and how that information is made available for the institutions and for the people. And regarding surface waters, we have the regulation associated to the flow. What it establishes is the amount of water that should be spilled, that should flow in a certain basin to ensure the conditions, the minimum conditions for the ecosystems, keeping a balance between the use and the ecosystems. The third element, very punctual element, has to do with the classification of the quality of the water beds. The country has 2 indexes for that, to classify the quality of the water beds. One index takes into consideration physical chemical elements of the water, and the second index takes into account the biological aspects of the water. Each one of them establishes the quality of the waterbed And based on that, the relevance of the monitoring and the results that we have obtained as a country. The fourth element has to do with the coordination, the forums for the coordination. And here we have an interinstitutional element of coordination that takes into consideration the water directory, the Waterworks and Sewage Company, the SENARA, the National Institute for Statistics and Census, and other stakeholders that have participation in the management of the hydro resource. In these coordination spaces, we also have the forums for citizens' participation. That has been an element that is very important for collecting and identifying the requirements that the people have in the different productive activities. And finally, the local management that has allowed us to bring down the level of attention to topics related to such as basins and waterbeds. These elements are included within the hydro policy and within the National Plan for Management. Currently, these two elements are under construction to be updated. With regard to the generation of data, in the operation of the directory, we have associated information that is being generated. For example, there are a couple of coordinates, geographic coordinates, that allow us to locate where the extraction for the water is located and how much water is being extracted from the waterbeds. In that map, we have information regarding the extraction of the water corresponding to the year 2020. And we can also observe that there are areas that are evidently with a higher level of extraction that are associated to the generation of hydroelectric power. Taking into consideration a couple of coordinates, geographic coordinates, in this map we can see the location of the water it takes, and through a geographic viewer, the people can click on one of the dots that we have there and obtain information of the use and the flow that is being used in each one of those specific spots. A series of maps similar to this one are generated for the quality of the water, for drainages, and for models of digital elevation. Also, the country has advanced in the implementation of remote sensors to determine the movement of the water on the ground in the wells of extraction. We have information in some of the wells since 2003, and this has allowed us to identify the variations of these levels throughout the months and throughout the years. Currently, we have 87 extraction stations or extraction wells that provide information in real time through the cell signaling. Another one of the advancements that we have generated as a country is through the teledetection, with an alliance that was generated with the support of the Ministry of Foreign Affairs and the Geological Service of the Survey of the USA, using the WAPIX technology. Maps have been put together for the potential of aquifers, taking into consideration different depths. For example, what is the potential of the aquifers from 0 to 30 meters of depth? From 30 to 150 meters of depth, and greater than 150 meters of depth. This is very important information for the country, for the management of underground waters. In the matter related to quality of the water, the country has 135 sites for monitoring. This is a manual network. What it implies is that we have to go to the field to collect the data and later analyze it at the lab. The information that is generated or shown there corresponds to the Central Pacific, and it shows the two indexes that I have mentioned in the beginning, the physical, chemical, and the biological indexes. According to the color, we determine the quality of the waterbed. This corresponds to an alliance between the institution with the academia, and it has allowed us to establish a baseline regarding the quality of the waterbeds. And to wrap up, steps to follow, it is very important to question ourselves if the legal framework contemplates this generation and dissemination of the information. It might be necessary to do an update, not only regarding the law for the water, but also for the elements of the planning. The integration of the efforts that are carried out by the institutions. In the map, what we represent is 5 intentions for the generation of basin management plans, which is a very important base for the country. We have to take into consideration the particular aspects of each one of the basins, but also at the institutional level, we have to look at a structure that is basic so that these plans might keep some sort of relationship. Here we have also worked with some other institutions of the academia, and we have had the support of the CATIE and other institutions and professionals that have added themselves up to this effort. And finally, the use and the application of the information, because we have made a very big effort as a country, but we have a very big challenge ahead of us at the moment of decision-making and the implementation of actions to be able to recover the quality of the waterbeds and to make a better management of the hydro resource in Costa Rica. Thank you very much.
Thank you very much for your intervention. Now we have Anina Kickinger. She has a master's degree in media informatics from the Vienna University of Technology and in advanced international studies from the Diplomatic Academy of Vienna. She has over 20 years of experience in software engineering. Her research interests have been focused on participatory design process and facilitating interdisciplinary knowledge creation and exchange. She has been working for international intergovernmental organizations since 2011. At UNOSA, she is responsible for the Space for Water project that she will introduce right now.
Thank you very much for coming here, and also the expressions of gratitude a bit short for the sake of time. I'll just extend that to all of you, your contributions, your efforts, your travels. But I would like to mention people who've not been mentioned today, which are the admins and the interns who've also contributed significantly. There's some people who we don't see who've contributed to this event that I would like to especially thank. Many of you know me already and we've been in touch. So I'll move straight into, can you put up my slides, please? Yeah. Why Space for Water? We've heard some of the drastic developments related to water and some drastic statistics. 40% of the world population are affected by water scarcity. 2/3 severely for at least a month per year. 2 billion people live in countries with inadequate water supply, and almost 9 million were displaced due to disasters in 2022, with 90% of the effects of all disasters being water-related. By 2025, half of the world's population could be in water-scarce areas. By 2030, 700 million could be displaced by intense water scarcity. By 2040, about 1 in 4 children will live under extremely high water stress. And yet 80% of wastewater is discharged untreated into the environment. Our aquatic ecosystems deteriorate, and this list could go on for a long time. Can you please go to the third slide? Next slide, please. Oh, here's my pointer, sorry. Sorry for that. Water connects so many of the SDGs, and we need to address the water agenda, which is alarmingly off track to be able to achieve many of these other SDGs. Space technologies and applications can help monitor more relevant water variables for the reporting of the SDGs than they're currently used for. And improving how we use water globally will contribute to changing climate change action, life below water, life on land. It's no surprise that water scarcity affects the water, energy, food nexus, but also our health, poverty, gender equality, and education. To achieve water security, we need to actively collaborate. And that's what we try to foster with this project. Space-based solutions for water can be grouped in 3 to 4 overall groups. One of them is Earth observation and remote sensing data. Others are spin-off technologies from human spaceflight, satellite communication, and navigation. Sorry, this is... So this slide gives you a brief overview of space-based monitoring. In some cases, this could be used for SDG monitoring, not in all cases. It is used in some. And we see that we can monitor changes in groundwater. We can monitor water quality to a certain extent indirectly. We monitor surface water extent, extreme weather events, surface water temperature, rising sea levels. We can look at oil spills and how they spread across the oceans. We can monitor vegetation health, soil moisture, and this is just to name a few. You will learn a lot more about this throughout the technical sessions of this conference. This graphic shows you this water cycle graphic that was developed by the US Geological Survey and published in 2022. And for the first time, and this is surprising, the human was integrated and included into this model that we know from our physics class that only contained like the transitions of the different states of water before. But the human element is critical when we think of our impact on runoff, reservoirs, agricultural water use, urban runoff, stream flow to the ocean. We need to consider the human element in the water cycle. And so this is why I put this up to be considered. At a glance, Space for Water fosters interdisciplinary knowledge exchange and the co-design of space-based solutions to address water challenges from source to sea. We build capacities in the use of space technologies to monitor water. You already heard today that this project is supported by the Prince Sultan bin Abdulaziz International Prize for Water, and an agreement was signed in 2016 originally. Since then, we've worked hard. In 2018, we launched a portal. 2020, we had a new agreement that goes until 2026 that allowed us to, for the first time, build a community of practice apart from the portal that publishes information. And this community of practice was critical in developing solutions, as you'll see later. Last year, we hosted 2 stakeholder meetings. And in 2024, we organized this conference. Today, we have 104 stakeholders, including many important space agencies, water agencies, and other actors working with water data who share experiences on the use of space technology for water. We'll also launch a webinar series in September that should allow us to stay in touch on a more regular basis, and that will cover lectures, trainings, and so on. We'll also have a Space Water stakeholder meeting. You'll learn more about that in a bit. The good news is we have a long-term perspective for the project that so far was able to bring together over 600 people from over 140 countries at the past 5 conferences. And we have a web portal with over 1,000 knowledge resources. We publish interviews. Space for Water portal allows actors to share information on the projects they implement using space-based data and technology. These sometimes seemingly complex technologies understandable. So we work on relating the knowledge from scientists to the general public. We publish an article monthly that you can see by looking at the scanning the QR code, you will get to the articles page. We also have these monthly interviews. And if you're interested in being interviewed, then you can scan the QR code on the right side. What is new is that we made a big effort to translate articles to Spanish and to French. Spanish was especially done for the sake of this conference and the community that will gather here, so they can access the information in Spanish as well. We also research training materials of partner institutions that we know. We publish information on events, conferences, trainings that are going on that you can participate. We have an integration with the NextGeo's dataset search, encouraging the use of standards instead of replicating the efforts. We point you there, and we develop a glossary of space terms apart from collecting local perspectives and case studies to link the international institutional level also back to the ground where people are affected by water incidents. Latest portal updates include that we have a search for collaborators. So people, actors can search for other stakeholders working in similar thematic fields on a local, national, regional, or international level in specific regions and so on. And we've been working heavily on the water-related challenges and space-based solutions. You will learn a bit more about that soon. The user base is constantly growing, and we have about 80,000 users per year. That was in 2023. On the left side, the QR code gets you to the Spanish translations of the articles. So this is just some statistics. I will skip quickly. Here we have some feedback from stakeholder meetings on their favorite knowledge resources. Surprisingly, it was opportunities and calls and announcements that the stakeholders wanted to know most about. They consider the software, web apps, APIs information as very critical. There is meta information on these. That's just an overview, and we take the feedback from the diverse user groups and actors into account. So this is from our stakeholders. Our users on the portal will have a different view. The Space for Water community today counts 104 stakeholders, 20 professionals, 26 young professionals, and 7 indigenous voices that we worked with. Here you see an overview of where they're located at. At stakeholder meetings, we foster interdisciplinary, multi-stakeholder knowledge exchange from the local to the global level. We work to co-design and develop space-based solutions. We meet once or twice a year, online and in person. And what you see here was a photo taken at a participatory workshop for Indigenous women on their roles and responsibilities related to water, where we had a mutual learning about how these communities relate to water, to space, to technology, and water-related changes they observe. And what was very important to me was to learn about their relation to technology and space as well, because we don't want to push solutions to them. I initiated that to learn from them, from the observations they made, and then try to help them to formulate water-related challenges based on the changes they observe in the environment. And we took that and put them on the portal. You can see them. You can also submit a water challenge that you have observed and would like to get addressed by the use of space-based data and technology here. And here I give you some examples. This was submitted by one of the professionals featured on the portal. And it is on Pakistan, who's faced with droughts and floods over the same region. He's describing this challenge. He brought it to the stakeholder meeting, and he has drafted a model that we're now working on developing in open source with other actors in the community. This is another challenge faced by the Maori tribe in New Zealand on river pollution and lacking historic knowledge on river course and vegetation. And you see somebody in the room who's actually contributed to addressing this issue. And this community got really active. They were so inspired by the knowledge that was shared during the stakeholder meetings that they felt empowered to start water sampling by themselves. That was without our help in the end. They worked with local authorities to get that going, and they could see maps that they shared with their elders. They gathered the whole community to look at the historic maps of the vegetation, and that was very important to them. And the solutions on how to create such data sets are on the portal, and we continue working with them. It's not, it doesn't end at the point where we have addressed some. We stay in touch with them to see how we can support them. That's another tribe in Kenya who's been faced with severe water scarcity, and they walk 20 kilometers to access water. And we actually outlined 3 solutions with the community that we're still working on. We're bringing in the Kenya Space Agency and local actors to address it. And there is still a lot of work to be done on the ground, but we have managed to develop maps for them. And the next step is for the creation of sand dams and rainwater harvesting to get some in situ data in the field that Kenya Space Agency was friendly enough to suggest to help collect for us. here is the solution that I mentioned before, where we now work with another young professional from a university in another African country who's willing to implement the model that was suggested by the Pakistani professional, so we can make this accessible to everyone in open source. It's a very complex model with several components, and once it's done, we'll share it with all of you. Outlook that I want to give you is that we will focus more and more on community building and on capacity building with the webinar series that will take place once per 3 months. It will be a 1-hour format where lectures, trainings, and panel discussions can take place. And that is to, on the one hand, have the continuity and regularly meet. On the other hand, allow for the stakeholder meetings to be very interactive, where we really can host hands-on sessions and strengthen the community and the knowledge exchange. Yeah, we also develop a vision for the future because we have a longer-term sustainability for the project, and we develop that vision starting to think about operational plans where we consider organizing technical advisory missions in countries on the use of space technologies to help countries to address their water issues. That's more of a longer term work that is more in depth with the countries, and I think that makes a lot of sense. So that will be coming up next, and we also look into expanding our resources so we can support the various actors and countries better. Space Water Project also aligns with the Water Action Decade, the Global Acceleration Framework, and the UN system-wide strategy for water that is currently being developed. So we look into how we can align our efforts to deliver as one as the UN and not replicate any efforts. And here you see some of the stakeholders that are actually in the room with us or participating in this event. And in case you also want to become part of the community, you can scan the QR code, but you also have that in the brochures. And I don't want to keep you from your lunch. So some brief announcements. The next stakeholder meeting, the 4th Space Water stakeholder meeting, will take place 23 to 24 October. This time it's online, and we'll focus on hands-on interaction to address water challenges. The registration form will be at the QR code, and it will open very soon. So for the conference series, I mean, this is where you're at. We've organized it every 3 years. We're thinking about new formats where we organize it on a more regional level to take into account regional needs, also reduce emissions. And on Friday, I'll circulate a feedback form where you can let us know how you think we can make this conference better. Thank you so much. And before we go to have our lunch, it wants us to go for lunch. Some logistics information for the conference. This is the QR code showing, getting you to the conference website. I hope every one of you knows it by now, but in case you need information on the conference, and we update the schedule there to get that. But what I want to tell you is, if you have any questions and you haven't had a chance to post them, such as in this session, because we're at the end, we created a form where you can post the questions that you didn't have a chance during the session to ask, and we collect them. Some of them will be addressed in the technical closing when we have a discussion, but if it's not been addressed, we'll forward your questions to the speakers. So if you have a question for one of the lightning talk speakers who are not with us, most of them are remote, please email isabelcetina@un.org. If you cannot connect to Zoom, and you're an online speaker or participant, please email James Zibacha consultor@ica.int. If you cannot upload your slides, check out the email addresses here. We'll help you. And with that said, one last point. So we would like to evaluate our project and learn about your user needs towards the Space for Water project to optimize the project's objectives for the next period. And to that end, my colleague Anne-Claire, who you see here in the back, will organize 2 focus groups on Wednesday and Friday during the lightning talk sessions. Some of you already agreed to participate. If you're interested in that, please approach Anne-Claire. Thank you so much. And enjoy your first lunch here.
Thank you all for this very interesting information. We have time for one question. So I like to give the floor now to the audience if anyone have a question. We have a question online, okay.
So for Mr. El Hadani, we have one question from the virtual audience. What are the water parameters that can be measured remotely by satellites?
So as I said in my presentation, there is a lot of parameters that could be measured using satellite data. For example, we can measure the soil moisture, for example, using SAR data, rather satellite data. This is one of the most important parameters that could support the development of irrigation. Satellite data is also used to measure, for example, through models, the evapotranspiration, which is important in the water cycle, for example. It's important also in the optimization of irrigation. We can also use satellite data to monitor dams, for example, the quantity of water in dams. Meteorological information is important from satellite, meteorological satellite to measure and to model precipitation, for example, which is important. Other parameters that are linked to water in a manner or another, for example, the drought impact, which is a combination of information from precipitation, from temperature, which is measured from satellite, and also vegetation health using the index vegetation, for example. So there's a lot of parameters that could be measured using the satellite data. And also indirectly, for example, satellite data could be used to support location of the most probabilistic places for water drilling, for example, combining parameters on geological features, on humidity, soil humidity, and also vegetation, though we can have different parameters combined to select areas that have a high potential for groundwater presence and support access to clean water in different areas, mainly in remote and desertic areas. So there is a lot of parameters that could be measured from satellite data, from precipitation to the quality of water, temperature of water. Satellite data could also help to measure the flow, the melting of glaciers. And as I said, there is a multitude of parameters that could be measured from satellites.